Mrs. Hill asked her students to express the sum 1 plus 3 plus 5 plus 7 plus 9 plus ... 39 using sigma notation. 4 different student answers were given. Which answer is correct? So here we're doing summations or sigma notation. Basic idea being that we add different numbers together, and we can use this notation to do it. So the first way that we're going to try to figure out what this is we should look at what's inside the sigma notation. So what's in here, and see which of these for the range given will actually give us the numbers that we have. So these are the numbers that we have. So really the best way to do this is just to test by making a table of values. So let's take some values for k, and in this case k minus 1. And I want to show you, I want you to try to guess which one is right before you start, so that you don't have to spend as much time guessing and checking. But I'm going to start with this one because I think you should be able to see pretty quickly why this can't be the answer. So if k starts at 2 and goes to 40, then those are the values we're going to write on the left. So 2, 3, 4, 5, ... all the way down to 40. So if we plug in 2 to the expression k minus 1, we get 2 minus 1 is 1. For 3, we get 3 minus 1 is 2. For 4, we get 4 minus 1 is 3, and so on. So clearly you can see this gives us 1, 2, and 3 as the numbers that we'll get out for k minus 1. That's not going to work. We need 1, 3, 5, 7, and so on. And by the same principle, so this isn't it. So by the same principle, 3 isn't going to work, because when we plug in k equals negative 1, the first one will give us 1, but the next one will give us k equals 0 plus 2 is 2, and that's not a choice, so this won't work either. And a clue in general when you take multiple choice tests is when you see 2 of the same, chances are that one of those is the right answer. So now the only question that we have to settle is, does k go from 1 to 20, or does k go from 1 to 39? And again, we can use the table of values. So let's try this one here. K and 2k minus 1, and then we can substitute in our values. So if we try 1, 2, 3, 4, and so on, then for 1 we'll get 2k minus 1 is 2 minus 1, which is 1. For 2 we get 2 times 2 is 4, minus 1 is 3. For 3 we get 2 times 3 is 6, minus 1 is 5. For 4 we get 2 times 4 is 8, minus 1 is 7. And now you can see we're on the right track, right? 1, 3, 5, 7, 1, 3, 5, 7. This is definitely going to work. But let's just make sure and test toward the end when we get up. We don't have to do every single one in the middle, but when we get toward the end, we're going to have 39. K equals 39. And what's going to happen when we put that in? We'll have 2 times 39 is 78, minus 1 is 77. Is that one of the numbers we're adding together? No. It only goes up to 39. So we certainly wouldn't want to go so high as to include a number like 77. So this must not be it either. It must stop at 20. And I'm not going to make a whole new table, but just to continue on this table, if we were to plug in k equals 20, what would we get? We would get 2 times 20 is 40. 2 times 20 is 40. Minus 1 is 39. And that's what we would expect to get for the last term. The last term is 39. So this expression is the one that will give us an equivalent sum to this. If you're really in a pinch and you have time, obviously you can add this entire sum together, and then you can also plug into your calculator. If you have the most advanced graphing calculators, they will take sigma notation. You can put this in and crank it out, and you should get the same answer. But notice, we were able to solve this problem without actually ever calculating what this summation equals, and without ever adding these numbers together.